Welcome to video 12.3. Today we're going to talk about phase changes. So remember that a phase change is when you change a state of matter. These are all physical changes. So anytime we hear the word phase or the term phase change, we're talking about changing states of matter. So a lot of times we are going to change the state of matter by heating a substance. When you heat a substance, particles absorb energy. That's important. Heating, you're adding energy. You raise the temperature because you've added kinetic energy, going back to the kinetic molecular theory. So the two things that happen is you increase the temperature, and that is just particles moving faster. Or you're going to break intermolecular bonds between two different molecules or atoms, and that changes the state. So when you take an ice cube and you add energy and you heat it so it melts, that is breaking intermolecular bonds. When you increase the temperature, that's just it getting to where it could change state. So heat is the transfer of energy from an object at a higher temperature to an object at a lower temperature. So if you were to take your hand and you were to put your hand on your desk, the desk would probably feel cold. That is because your hand has more heat than the desk does. It has more energy. So right now, if your hand is on your desk, you are going to end up transferring energy from your hand to the desk. And that's from a higher temperature to a lower temperature. So we've got our solids, our liquids, and our gases. Remember that every particle is moving. Whether it is a solid, it is a liquid, or it is a gas. How much it moves and how far apart the space is between each particle depends on if it's a solid, liquid, or gas. So remember, solids are tightly packed. They have strong intermolecular forces. Liquids are kind of tightly packed. They take the shape of their container, and they have weak intermolecular forces. And gases are not packed at all. They have lots of empty space between each of their particles, and they have no intermolecular forces. So right here, you can see the different phase changes. We've got melting, freezing, condensation, vaporization, sublimation, and deposition. We're going to talk about each of these in depth. So the first one, when you're heating ice, the ice eventually absorbs enough energy to break hydrogen bonds that holds the water molecules together to melt. When those bonds break, the particles move apart and the ice melts into water. So that's called the melting point. When they first absorb energy, a solid absorbs energy, and then they've got too much energy to hold, so the bonds break. The particles move apart. Anytime you're heating something, you're adding energy. If you're putting energy in, that's called endothermic. Melting is an endothermic reaction. When you're melting something, you have a solid that becomes a liquid. And the specific melting point is a specific temperature where the crystalline solid forces that are holding that crystalline solid together are broken. And so the intermolecular forces break apart. It's no longer a solid, it's now a liquid because you put too much energy in. So going with talking about putting energy in, when you go from a liquid to a gas, you're putting energy in, typically in the form of heat. And a lot of times we call that boiling, or we call that evaporation. But it's actually called vaporization. So vaporization is the process by which a liquid changes into a gas. Again, you keep adding energy until those liquid bonds are too overwhelmed with adding energy and they break apart. So vaporization is your process by when liquid changes to a gas or a vapor. Evaporation is a type of vaporization, and it happens only at the surface. So evaporation Like if you set a cup out on a hot summer day, evaporation would happen at the surface of that liquid. Boiling is different. Evaporation is a cooling process, so your sweat is being evaporated off of your body. It has a high kinetic energy. Not many molecules actually get there. And because at higher temperatures things evaporate faster because they have more kinetic energy. So if you heat something up to a higher temperature, or if it's hotter outside, things will evaporate faster because particles have more energy individually. So when you've got this lower temperature, you're going to have more particles at this lower amount of kinetic energy. If you have a higher temperature, you're going to have more particles at a higher kinetic energy. Now, vapor pressure is part of vaporization, and that is the pressure exerted by a vapor over a liquid. So, in this open container, you can see that all of this water, liquid water, and then the vapor water vapor above it, it can escape. When it can't escape over a closed container, you're going to have either boiling happen, or you're going to have an explosion. We would rather have boiling happen. Well, what is boiling? Boiling is the temperature at which the vapor pressure equals the atmospheric pressure. The boiling point for water is 212 degrees Fahrenheit. That is the temperature at which the vapor pressure of the liquid equals the atmospheric pressure of the atmosphere. This is also 100 degrees Celsius. But how are evaporation and boiling different? Well, remember, they are both types of vaporization. But boiling occurs throughout the liquid. Evaporation only occurs at the surface. And boiling occurs at one specific temperature. So that's when your external pressure, or your atmospheric pressure, equals your vapor pressure. So that means that boiling has to happen at a specific temperature. For water, it's 100 degrees Celsius. But evaporation can happen at any temperature because it always happens only at the surface of the liquid. So since it happens at the surface of a liquid, and it can happen at any temperature, you can have evaporation happen when it's winter outside. Boiling is not going to happen unless you apply heat. Evaporation can happen at any temperature. Our other type of phase change that requires energy. So we've talked about melting, you're adding heat. Vaporization, you're adding heat, is called sublimation. And sublimation is the process by which a solid changes directly into a gas without becoming a liquid. So this is where you go not gas. You go from a solid to a gas. We will do the dry ice lab. And dry ice is solid CO2 that then goes straight into sublimating to gaseous CO2. These are phase changes that require energy. Typically in the form of heat. So now we've got other phase changes, and these are changes that release energy. So this is typically where something's going to cool, is what we call it. And this is where heat flows to the surroundings and particles lose energy. This is called the freezing point, and that's a specific temperature in which a liquid is converted to a solid. We like freezing points when it comes to getting snow days. So the freezing point is a very specific temperature, and for water it is 0 degrees Celsius. So that's freezing is going from a liquid to a solid. When you're talking about water vapor, and when a vapor, which is a gas, loses energy, that means that the particles slow down. So a gas would then condense into a liquid. That's called condensation. So condensation is when you have a gas becoming a liquid. It is the opposite of vaporization. And remember that freezing is the opposite of melting. And then we have our third and final phase change, our sixth phase change, for our third that releases energy. And this is called deposition. So deposition is when a gas or a vapor changes directly to a solid. And then is the reverse of sublimation. So this is what happens at high pressures underneath the Earth's surface. So if you look at these, our endothermic processes absorb heat. You have to apply heat to them. So melting and boiling, which actually should right there say vaporization. So I'll cross out boiling and write vaporization. And then to go here from a solid to a gas, an endothermic reaction, that would be sublimation, because you do have to add heat. To go from a gas to a liquid, that would be called condensing. To go from a liquid to a solid, that would be called freezing. And to go up here from a gas to a solid, that's a really sad looking arrow. But to go from a gas to a solid, that would be called deposition. So thanks for listening about phase changes. Make sure that you know the difference in each of our 6 types of phase changes, and when you add energy and when it releases energy, typically in the form of heat. Thanks so much.